Our next topic is chemical properties of arenes. Arenes are highly unsaturated. They are behaving like the saturated hydrocarbon, but however they are more reactive than saturated hydrocarbon but less reactive than alkenes and alkynes. Why they are highly stable? It is because of the delocalization of pi electrons or resonance. Because of that resonance they are highly stable, so they are behaving as a saturated hydrocarbon. So they are showing the chemical properties similar like the saturated hydrocarbon, not like the alkenes and alkynes. So first chemical property which we will be going to study in arenes is a substitution reaction. In substitution reaction there is a replacement of one atom or group of atom by another atom or group of atom, that is a substitution reaction. So first substitution reaction which we will be going to study in arenes, that is halogenation. So in halogenation what is happening? First of all, this reaction is taking place in the low temperature in the presence of halogen and catalyst. This catalyst is Lewis acid. It means they are electron deficient. So because of the electron deficiency of these catalysts, this reaction is taking place. It means the substitution reaction in arene is initiated by the help of catalyst. So what is happening in this case? In the presence of chlorine, the reaction is taking place at the low temperature around 310 to 320 Kelvin, and in this catalyst which are taken either AlCl3 or FeCl or FeBr3. So these are the some catalysts which are behaving as a Lewis acid, which are initiating substitution reaction in arenes. So what is happening in this case? There will be formation of chlorobenzene is taking place and removal of HCl. One of the hydrogen of this benzene is replaced by the chlorine. So this reaction is known as substitution reaction. Similar reaction is taking place in the presence of bromine. So what is happening? So similar reaction is taking place in the presence of bromine, anhydrous FeBr3 in the presence of anhydrous FeBr3, and the reaction is taking place at low temperature. So there is a formation of bromobenzene is taking place and removal of HBr. Similarly in the case of toluene, if we take toluene and react it with chlorine in the presence of anhydrous AlCl3, and the temperature of the reaction is 310 to 320 Kelvin. So there is a formation of orthochlorotoluene is taking place. It means in this case there is mixture of products are obtained. One is orthochlorotoluene and other is parachlorotoluene. This is parachlorotoluene, this is orthochlorotoluene. The stability of orthochlorotoluene is less, so this is minor product, whereas the stability of parachlorotoluene is more, so it is major product. So this is the major product which will be obtained in the reaction mixture. Further, so if we react benzene in the presence of excess electrophile, if we take excess electrophile, so this is excess electrophile in the presence of anhydrous AlCl3. So the reaction is taking place at dark, at very low temperature. Then there is a formation of hexachlorobenzene is taking place. So there is formation of hexachlorobenzene is taking place if excess of electrophile is taken. All 6 hydrogen of benzene are substituted with chlorine atom. This reaction, this halogenation can also takes place if we take iron. So if we take iron in the presence of chlorine, that is electrophile, so there will be formation of chlorobenzene is taking place and removal of HCl. So what is happening in this case? In this case, first of all, this iron will react with this electrophile. So what is happening? Further, iron will react with electrophile to iron. So there is a formation of 2 moles of FeCl3 is taking place, which is behaving as a Lewis acid. Further, this FeCl3 will initiate the reaction. It will be behaving as a halogen carrier. So further it is behaving as a halogen carrier, which is initiating further reaction, that is substitution. Next halogenation reaction is iodination. Iodination is not that much useful. It is because it is a reversible reaction. Why it is reversible? Because of the formation of Hi, which is behaving as a reducing agent. Because of that, this reaction become reversible. So this reaction is taking place in the presence of oxidizing agent, example HiO3, HGO and HNO3. If these oxidizing agents are not used during the reaction, this reaction has no significance because it will become reversible. So what is happening in this case? In iodination, benzene is reacting with iodine. The reaction is reversible. So there is a formation of iodobenzene is taking place and removal of Hi. So why it is reversible? It is because of the formation of this hydrogen iodide, which is behaving as a moderate reducing agent. So it will again react with this iodobenzene and this reaction moves towards a backward direction. Because of that, this reaction has less significance. So to remove this Hi, that is hydrogen iodide, from the right hand direction of the reaction, so we use oxidizing agent like HiO3, which is iodic acid, HNO3, nitric acid, or we can also use HGO, which is mercurous oxide. So what is happening? If we use oxidizing agent HiO3, so it will react with Hi. 5 moles of Hi are taken. So there is formation of 3 H2O molecule and 3 I2 molecule. If we use nitric acid, 2 moles of Hi. So this nitric acid will react with Hi. We have to balance the reaction. So there is formation of 2 NO2 and 2 H2O and 1 I2 molecule. If we take HGO, if we use HGO as an oxidizing agent, then there will be formation of Hg. I2 is taking place, which is mercuric iodide, and removal of H2O is taking place. So these are behaving as an oxidizing agent. Benzene is generally giving electrophilic substitution reaction. It is because of the presence of 2 electron cloud above and below the plane of the molecule. Because of the presence of these loosely held pi electron cloud, they are behaving as a nucleophile. Because of that, they are attracting electrophile and repelling nucleophile. Because of that, they are giving electrophilic substitution reaction. They are not giving electrophilic addition reaction like alkenes and alkynes. It is because of the conjugation of these pi electrons. Because of the resonance conjugation, that is delocalization of pi electrons, benzene is more stable in comparison to alkenes and alkynes. Because of that, they are giving substitution reaction. So because of these two reasons, benzene is giving electrophilic substitution reaction, in which we have studied one substitution reaction, that is halogenation. So let's see how the mechanism is playing role in the case of halogenation. So before writing the mechanism, first of all you have to write the general reaction. So what is happening in halogenation? First of all, benzene is reacting with electrophile in the presence of catalyst, that is anhydrous AlCl3, and the reaction is taking place at very low temperature, that is 310 to 320 Kelvin. So because of that, there is a formation of chlorobenzene is taking place and removal of HCl. This is electrophilic substitution reaction. What will be the mechanism behind this reaction? First of all, there will be generation of electrophile, and this electrophilic generation is initiated by the catalyst, that is Lewis acid AlCl3. So this Lewis acid is electron deficient. Because of that, this initiate this halogenation reaction. It means it will initiate the generation of electrophile. So what is happening? This chlorine molecule will react with AlCl3. So there is a formation of a polarized molecule is taking place. Because of that, there is breaking of this Cl bond is taking place. It means this bond will be polarized. So in this case, there will be partial positive charge will be coming on this chlorine and partial negative charge is coming on this part. So this bond is becoming longer from the normal covalent bond. Because of that, this is behaving as a polarized molecule. These Lewis acids are behaving as a halogen carrier. In second step, there is a formation of sigma complex is taking place. So what is happening in this case? This polarized molecule, this halogen carrier, in which there is partial negative charge is coming on this part, partial positive charge is coming on this part. So it is behaving as an electrophile, electron deficient. When this bond will be shifted towards this, because of that, this chlorine will attach on this position of the carbon, whereas positive charge will be coming on this position. So because of that, there is a formation of carbocation is taking place. So in this case, there is a formation of carbocation, that is positive charge is coming on this carbon, and at this position there will be attachment of chlorine, and also in this position there is one hydrogen is present. So what is happening? This is called sigma complex and also known as reactive intermediate, that is carbocation. So in this case, there is a formation of this sigma complex is taking place and removal of AlCl4 minus. So what is happening? This sigma complex is resonance stabilized. So how this is resonance stabilized in this case? So this sigma complex is resonance stabilized. So what is happening in this case? This pi bond will be shifted towards this side, due to which positive charge will be coming on this position. So it is resonance stabilized sigma complex. So there is formation of pi bond in this place, hydrogen Cl, and positive charge will be coming on this position and one pi bond at this position. Further, this pi bond will be shifted towards this position. Because of that, the positive charge will be coming on this position. So further, what is happening? Pi bond is coming in this position, one pi bond at this position, and positive charge is coming on this position. So there is resonance stabilization of this sigma complex is taking place, in which there are three canonical structures are formed. So there are three canonical structure. So final structure, that is resonance hybrid. What will be the resonance hybrid? So it means delocalization is not complete. It is occurring from this carbon position to this carbon position. So there is a partial delocalization, and because of that, this is the resonance hybrid which will be formed. So this is the sigma complex, that is carbocation, which is formed in the second step, and this step is a slow step. So this will be rate determining step. Why this is rate determining step? Why it is slow? slow? It is because more stable benzene is converted into less stable carbocation. Because of that, this reaction is slow and it is rate determining. There is removal of proton is taking place in the third step. So this is the sigma complex from which there will be removal of proton, that is H plus. So what is happening? In the presence of this proton will be removed, so the shared pair of this bond will be shifted towards this position. So the shared pair of this carbon hydrogen bond will be shifted towards this position. So this ion will abstract this H plus. So there is a formation of AlCl3 and HCl will be taking place, and the main product will be chlorobenzene. So what is happening in this case? This AlCl4 minus will abstract this H plus. This bond, that is carbon hydrogen bond, that is shared pair of electron, will be shifted towards this position. Because of that, there is removal of H plus, and this H plus will be abstracted by this AlCl4 minus. So there is formation of AlCl3 and HCl is taking place, and the main product which will be formed is chlorobenzene. So this is the mechanism of halogenation when the reaction is taking place in the presence of Lewis acid. Next substitution reaction is nitration reaction. So what is happening in this case? Before writing the mechanism of reaction, you have to write the general reaction. So in nitration of benzene, we use nitrating mixture, which is mixture of concentrated HNO3 and concentrated H2SO4. So in this case, what is happening? First of all, write the general reaction. In the presence of concentrated HNO3 and concentrated H2SO4, so the mixture of concentrated HNO3 and concentrated H2SO4 is known as nitrating mixture. So this reaction is occurring at the temperature that is 323 to 333 Kelvin. So there is a formation, it means substitution is taking place. One hydrogen of the benzene is replaced by NO2. So there is formation of nitrobenzene is taking place, and removal of H2O is taking place. So the mechanism of this reaction is just similar like the halogenation. In this case also, there will be first generation of electrophile, second step will be formation of carbocation, that is sigma complex, and third step there will be removal of proton. So let's see how the mechanism is taking place. So first, there is generation of electrophile. So what is happening? In this case, H2SO4 will release H plus ion. It means it is behaving as an acid, whereas concentrated HNO3 is behaving as a base, which is abstracting H plus from the H2SO4. So what is happening in this case? H2SO4 will ionize to H plus and HSO4 minus. This H plus then attack on HNO3, because there is, we know that in the case of HNO3 there is 3 oxygen. So what is happening in this case? This oxygen which is attached to the hydrogen which is having a lone pair, so this electrophile will be attracted by the lone pair. So what is happening? There is a formation of protonated nitric acid will be taking place, in which positive charge is coming on the oxygen, and we know that positive charge on oxygen is unstable. This is protonated nitric acid. So what is happening? This shared pair of electron, that is bond of oxygen and nitrogen, the shared pair of the bond will be shifted towards the oxygen. So there is a formation of H2O is taking place and formation of NO2 plus. This NO2 plus is a nitronium ion which is behaving as electrophile. So this is behaving as an electrophile which will attack on the benzene ring, and there is a substitution will be taking place. Second step, we know that In the case of benzene, there are pi bonds, pi electrons, and these pi electrons are loosely held. Because of that, it will attract the electrophile, this electrophile, that is NO2 plus. So what is happening? NO2 plus will be attracted by the pi electrons. So there is a formation of carbocation is taking place. At this position of the benzene, there will be positive charge because this bond will be shifted towards this carbon. Because of that, there will be negative charge, and at this negative charge, this NO2 plus will attack. So there is formation of this sigma complex is taking place, in which there is 2 pi bonds are left. So this is the sigma complex or carbocation, and this sigma complex is resonance stabilized. So there is partial resonance stabilization. It means partial delocalization is taking place. This pi bond will be shifted towards this position. Because of that, pi bond will be coming on this position and positive charge will be coming on this position, because this pi bond is shifting to this position, and NO2. Further, this pi bond will be shifted towards this position. Because of that, positive charge is coming on this carbon of the benzene. So further, what is happening? There is formation of in this case, there is positive charge, pi bond will be coming on this position and on this position. So there is partial resonance stabilization. It means resonance, that is delocalization, is taking place from this carbon position to this carbon position, not at this carbon, because in this case there is no pi bond, due to which in this case there is only partial delocalization is taking place. It means partial stabilization. So the resonance hybrid which will be formed, so there is partial stabilization from this carbon position to this, and one hydrogen is present on this and NO2. So there is partial delocalization of this positive charge. So this is resonance hybrid. Further, what is happening in third step? In third step, there will be removal of H plus ion, that is removal of proton from this sigma complex. So what is happening in this case? So what is happening in this case? This hydrogen which is attached on this carbon will donate its shared pair of electron towards this position. So why it is donating shared pair of electron to this position? Because of this HSO4 minus anion. This HSO4 minus anion which is present in this first step, which is behaving, this H2SO4 is behaving as a catalyst. So what is happening? This HSO4 minus will again abstract H plus from this sigma complex. So what is happening? This will abstract this H plus. So the shared pair of carbon hydrogen will be shifted towards this position. So there is formation of nitrobenzene is taking place and removal of H2SO4. So these are the 3 steps in nitration. So this is electrophilic substitution reaction.